Hi, I'm Karthik from Prescient. I'm here to talk about how we continue to change the world of data operations for many industries. This includes fields like statistical process control. So today we'll be talking about anomaly detection. This will be with the help of our anomaly detection node that is exclusively available on the Prescient Designer. So what is anomaly detection? It's a way to find out outliers in data. That's basically glitches, faults, and abnormal behavior of any sort. Finding out anomalies is a crucial part of making sure your system is working under normal circumstances. It's a way to filter out bad data and a method to find out if your system is in trouble of any sort. This can be done instantaneously on this node. So in the node, the data to be processed can be treated in a couple of ways. It's either windowed or instantaneous. So what this basically means is that the data that is input is treated as a window, which is either defined by a set of points or a time interval. And all these points create one output which tells us whether it's an anomalous window or not. The other way is finding out anomalies in an instantaneous fashion, where you have anomalies being detected over a window but in an instantaneous manner for every point that is coming in. So the kinds of anomalies that we can detect with this particular system are: number one, pattern matching. So making sure that the incoming data is following similar patterns to what it has exhibited before. And these can be pretty complex patterns as such. Number two is standard deviation. To check if the standard deviation is in bounds of whatever limits you have set. This reflects on the trend of data and the spread. Number three is average, which also correlates largely to how anomalous the incoming data stream can be. Number four is a simple one, that is threshold, whether checking if every point that is coming in is anomalous by checking what threshold values it lies between. So this system as such runs on the Prescient Designer. The Designer is a low-code platform that solves the hardest problems in a modular and extremely efficient manner. The platform permits evolution of projects, and solutions built on this is one of the easiest ways of future-proofing it. So we'll be looking at an example of this on this Prescient Designer tutorial. So what we are looking at now is the Prescient Designer, and this is where you can find the nodes. In the search itself, you can find the Anomaly Detect node. What we have here are a couple of inject nodes, which we are just going to use to test the node. And on the right, we have a message.payload, which behaves like a data destination. So in reality, you can swap this out with any data connector that you want. This can be swapped out with any data destination that you want. And so that's the real advantage of the designer here. On the right here, we can see the debug node, the debug output. And so this is what the node really looks like. As we mentioned earlier, we can see that this is windowed processing or instantaneous processing, however you want it. What kind of violation would you like to detect? The average, standard deviation, pattern violation, or threshold based? Should it be in point based, that is the number of points that are going in, or the time period? Since we've selected points here, it checks how many points you want, the lower threshold and the upper threshold. You can find out more information about this particular node over here. So this specifies exactly what was said just now. It's in a little more detail, and you can go through this with an example too. And now let's just see one basic principle on how it works. So whenever I choose point, so just as a starter for you, if you choose, like, suppose 10 points, then now your window size chosen here is of size 10, and it will keep checking for an anomaly average of an average based anomaly, and you can choose an upper threshold and a lower threshold. That is, if the mean is outside the two of these values, then what to do. So for example, any mean that we get from 3 and 4, that will always lie between 3 and 4. So suppose we keep the lower threshold as 0 and you don't want your mean to go above 2. So this is going to produce an anomaly always. So let's just see that it works. Yeah. So right now we are passing in the window. We are passing in around 10 points, and here it is. So one shows that it's an anomaly, and what has basically happened is, since the mean was between the values of 3 and 4 and the upper threshold we put in was 2, there was a violation created, and hence the anomaly was detected, was indicated. So this is a basic starter. You can always reach out to find out more about the node. Thank you so much.